Hi, this talk is about our paper Efficient Nearest Neighbor Prompt-Based Learning for Few-Shot NER in Manufacturing. Our paper appears as a SMEC presentation at SMEC 2024. It is a joint collaboration with Pei-Yan Wang and myself. NER in manufacturing involves entity types such as part, attribute, material, and accessory in various documents related to mechanical manufacturing. In this example, Hicheng Shinke Syntec Core is an entity of accessory and 25M1in is an entity of value in manufacturing. The morphology of characters contribute to its overall entity meaning in word formation. For example, in the entity length from G, air cooler device used to generate cold air. The character length, cold, denotes temperature properties. Feng wind serves as a fluid medium, and G machine represents equipment. Diving into the actual production of the paper, we start with the motivation. Two main characteristics of manufacturing-related texts result in a limited number of annotated samples available for training. First, there are 11 types of entities, which much more than entity numbers of general domain. Therefore, there are fewer entities of each type compared to the general domain in datasets with the same number of sentences. Second, the annotation of manufacturing-related text imposes a significant challenge as it requires expert knowledge. Recently, prompt-based learning has succeeded in few-shot NER by exploiting prompts as task guidance to increase classification efficiency. But this work did not fully learn the morphological features of character in the manufacturing entity, when label data is limited. To address these issues, we propose a nearest neighbor prompt-based learning model, which utilizes instances-based retrieval to enhance the template-free prompt tuning method and achieve competitive results for few-shot NER in manufacturing. Besides, existing manufacturing-related texts have a phenomenon of multi-category characters. These characters refer to those characters with two or more entity types. Since the representations of the same characters in different entity types still have a greater similarity than those of two different characters. The character representations from PLM perform poorly in retrieving similar morphology of characters. Therefore, we propose a supervised contrastive learning SCOL-term instance weighting method to address such challenge. The SCOL pushes character representations from the same label close and character representations from different label feature apart in the space. The NenPlum consists of three parts: the enter module, the module, and the Viterbi module during inference. The probability distributions of each token are obtained from both the NTLM and modules. These two probability distributions are weighted and summed, and the result is fed into the Viterbi module to obtain a final label sequence. Next, we introduce each part details. For the vanilla NER model, we use the template-free prompt tuning method, entity-oriented ELM and LM for few-shot NER in manufacturing. In ENT-ELM, the PLM is fine-tuned to predict label characters instead of the original characters at the entity positions. While still predicting the original characters at non-entity positions, then in order to enhance disparity between representations from different labels, we introduce SCOL-term to fine-tuning PLM. The SCOL pushes token representations from the same label close and token representations from different label feature apart in the space in this section. The data store is the set of all key value pairs constructed from all labeled characters in the training set, where the key is the representation of characters and the value denotes the labeled entity type. In addition, we also introduce a weighting factor to each key to modify distribution of NEN. The key is given a weight proportional to the similarity it causes. The larger is the negative difference differing the mean distance of keys from the same label and the mean distance of the keys from other labels, the larger is the weight. Diving into the results, we can see that. First, NenPlum improves the competitive baseline into ELM by 7.2% in average F1 score on all few-shot NER datasets. This indicates that NEN module is able to provide task-specific instances information to enhance prompt-based model. Second, we can observe that with the decreasing number of the training examples, Our model tends to achieve greater improvement, even the data store is also limited by the lowest source. In addition, we update the NAM module and school objective to validate its effectiveness. NaN-only data store means only using data store in NaN module and is described by alpha1 in the weights. Then, data store weights donates using the data store and weights in NaN module without scale. Squirrel indicates the fine-tuning by our proposed and LMS CL without NaN module. From table, we notice that NaN data store weights, NaN data store weights, and SCL perform significantly but NTELM demonstrate effectiveness of NaN module and SCLE objective. Moreover, when the number of instances is less than 200 shot, NaN performs a little better than such methods. This demonstrates that the superiority of our framework in few-shot manufacturing NAIR. We also explore why adding SCLE objective better than only NTLM by visualizing representation. We train PLM on 5-shot setting and use TSME to project the high-dimensional representation into 2 dimensions, where the high-dimensional representation are the last hidden representatively PLM. In figure, we can clearly see that the SCLE term enforces more compact clustering of characters with the same label, while the distribution of the representations learned with only NTLM is close to random. Note that a few representations from NTLM overlap with representations in the other entity types. In our method, the representations of different entity type are separated clearly. Therefore, our method rectifies the prediction cost by the representation of predicted characters more likely to fall into the cluster with a gold label. Finally, we select a typical example to better illustrate the amendment by NaN retrieval. For the input sentence, He Cheng Sin Caillou Feng Woshin Bian Yuan DG, but joined between synthetic core and honeycomb core edge. He Cheng Sin Kai synthetic core belongs to the accessory entity. The NTLM makes an incorrect prediction as this model does not fully learn the morphological features and multi-category characters phenomenon in a factoring under few-shot setting. However, NaN rectifies the prediction by retrieving the nearest characters with a similar morphology, such as He, combine of He Chengxin Sin Kai synthetic core, and Rong, fusion of Rong G solvent, have similar meanings and are both the first character of the entity and avoiding the same characters with different labels. There are some bibliographical references in our paper. Thank you for your time.